So we've come to the point where we've talked about all of our conic sections. We've talked about our circle, our parabola, hyperbola, and ellipse. And we've talked about them all individually. Now we're going to kind of throw them all together. And we're going to be asking you to be able to identify what kind of conic section it is based off of the equation. We're also going to look at converting from general form to standard form, and then from standard form to general form. So we've been going into standard form, and we've done general to standard quite a bit. That's where we complete our square. But we also can go from standard to general. So we kind of mix it up a little bit and kind of working with some multiplication. So we want to first look at identifying conic sections from general form. So what are some things that I look for as I kind of examine what's happening with the conic section and what kind of conic section it is? Well, the first thing I look for is how many square terms are there? We had a parabola. We also had circles. We had an ellipse. And we had hyperbolas. Our parabola is the only one that had one squared term. All these other ones had squared terms. So if we only have one squared term, we know it's going to be a parabola, and that's going to be good to go. What do we know about a circle versus an ellipse? We know that these are very similar to each other as we've studied them. A circle, though, set of all points equidistant from one point, and the ellipse is a sum of all points from 2 points, or the foci. In these, we are both adding we're adding two values, so we know that the squared terms are all going to be positive. Well, if they're going to be positive, we also know that a circle, for it to be equidistant, those coefficients of the squared terms have to be the same. So coefficients, squared terms, are equal and positive. In ellipse, the coefficients are going to be different for the squared terms. And they're both going to be positive. A hyperbola is going to be the difference between the 2 points. So we know a hyperbola, we're going to have one positive and one negative coefficients of our squared terms. And that's going to give us basically what we're going to be looking for to be able to identify what the conic section is. So let's go ahead and run through a couple of examples here and see if we can't pick out which one is which. So in example 1, we have an x squared and we have our y squared, and really I'm only looking at the squared terms. The rest of it really doesn't matter a whole lot to me. So if I have an x squared and a negative 4y squared, I see I have a positive and one negative value for my x's and my y's. So I know this has to be my hyperbola. In example 2, as I look at my squared terms, I only have one squared term. If I only have one squared term, I have a parabola. In my next example, example 3, I have 9x squared plus 4y squared. Again, not interested in this extra stuff. Notice our coefficients are being different. If they're going to be different, I have an ellipse. In my last example, I have x squared plus y squared. So two squared terms. My coefficients are both 1, so I know I have a circle. And those are the things that I'm going to look for as I figure out what I'm working with. To be able to convert from general to standard, that's where we're coming up with and doing our completing the square. So I'm not going to spend a whole lot of time with this because we've done quite extensively with this. But if I have x squared minus 4y squared, I know this is an hyperbola. Not that it asked for it, but we know it's a hyperbola. Can we go ahead and go from general to standard? So this is our general form. Standard form, we're going to pull the x's together. We're going to pull the y's together. And we're going to go ahead and set it equal to our constant. Now I'm going to go ahead and complete the square. I'm going to go ahead and complete the square with my x's. Negative 6 divided by 2 and squaring it, I get 9. So I'm going to add 9 to both sides. Over on this one, I'm going to go ahead and factor out that negative 4. So I get y squared plus 4y. I'm going to complete the square with my 4 divided by 2 and squared. So 4 divided by 2 squared gives me 4. But I didn't just add 4 to this side, I actually subtracted 16 from this side. So I can go ahead and subtract 16 from this side. Remember, if we do something to one side, we got to do it to the other. I can go ahead and factor. So I get x minus 3 squared minus 4 times y plus 2 squared. And that's going to equal 11 plus 9 minus 16, which is going to be 4. Remember, hyperbola, we want to go ahead and set it equal to 1. So I'm going to divide all of my terms by 4. So I get x minus 3 squared divided by 4 minus y plus 2 squared. You can put it over 1 if you want. Those 4's are going to cancel, and it's going to equal 1. So from here, we can go ahead and graph it. We can find the center. We can find our transverse axis, our conjugate axis, whatever we needed to do with that. Converting from standard to general. This is something that we haven't practiced a whole lot with. But nonetheless, it shouldn't be too difficult for us to do. So what is it to get it from standard to general? Well, we just did an example of going from general to standard. So notice we have all of our terms on one side. We have our x's squared, then our y's squared, then our x's, then our y's, then our number equal to 0. And that's the kind of the form we want to get it into. So what can we do with this in order to get it into that form? The first thing I want to do is go ahead and get rid of these fractions. What can I multiply by to get rid of dividing by 4 and dividing by 16? So if I divide or multiply both sides by 16, I can go ahead and get rid of these two fractions. So 16 times a quantity divided by 4 is the same as multiplying by 4. So I have 4 times x minus 3 squared. I'm going to multiply the 16 to my y plus 6 squared and then divide it by 16, so the 16s will cancel. So you get y plus 6 squared, and that's going to equal 16 times 1, or 16. Don't forget to multiply the 16 to the other side as well. Now I just got to multiply this out. X minus 3 squared, we get x minus 6x plus 9. Multiply the y plus 6 out squared, I get y squared plus 12y plus 36, and that equals 16. I'm going to multiply my 4 through. Oh, I missed my squared. So I get 4x squared minus 24x plus 36 plus y squared plus 12y plus 36 equal to 16. Now to get it into general form, I'm going to go ahead and get my x's first, squared, and then my y squared, so that takes care of those two terms, then my x linear term, and then my y's linear term, and then my constants all to one side. So I have 36 plus 36 minus 16. If I subtract my 16 over, that would give me 20, plus my 36 gives me 56, and that's going to equal 0. And that's going to be my general form. I have just one last example here. We have a circle that we're going to get from standard form to general form. Again, we're going to go ahead and square out the x minus 2 squared, so we get x squared minus 4x plus 4. Squaring out y plus 5 squared, we get y squared plus 10y plus 25, and that's going to equal 45. Bring my x squareds first, and then my y squareds, then my linear x's, my linear y terms. That takes care of all of those. I'm going to add my 4 and my 25 together. I'm going to subtract my 45. So it looks like we get, what, negative 20 there, a negative 16, and equal to 0. So that gives you an idea of things to look for to see if we have what conic section that we have that we're working with, and also converting from standard to general form. If you have any questions, join a Zoom, and good luck.